review process must be followed. An environmental impact statement, or EIS, and mining permits must be obtained from the government. The environmental impact statement is an in-depth environmental review and study of how the mine's activities and processing plant would impact the environment, human health, and the economy in Minnesota. The EIS and permitting process includes not only scientific studies, economic impact studies, and sampling of the environment around the proposed mine, but also public meetings so people can share in the review process. Permits to mine take into account all the information developed in the EIS and define requirements the mining facility must operate under in order to comply. The permit to mine also includes the mining company's agreements on how the disturbed areas will be returned to a natural state once the end of the mine life is reached. This phase of the environmental process is known as mine land reclamation and is often done during the active life of the operation or shortly after the end of the operation. Reclamation consists of modifying the disturbed land and returning it to a more natural state of hills, grassland, forests, and lakes for the benefit of future generations. The pits left behind from iron mining will become lakes where fish are stocked, and depending on future land use needs, shorelines could include residential developments, cabins, resorts, or public lands. Once all the permits, restoration plans, and financial assurances are in place, mining can begin. As one can imagine, the permitting process takes several years. Taconite is the term used to describe the iron-bearing rock found in a portion of the Mesabi Iron Formation. It's an extremely hard rock and contains around 30% iron. Using explosives, the iron ore is blasted into chunks small enough to handle in large excavators. The largest excavator on the Iron Range can hold up to 65 tons of rock. The machines place the taconite rock into giant haul trucks. These trucks are as big as a house and hold up to 240 tons of rock. The trucks take the iron ore directly to the processing plant and the unneeded overburden to the nearby stockpiles. At the processing plant, the ore is crushed into even smaller pieces by rock crushing machines. The crushers keep crushing the rock until it's the size of a marble or smaller. The rock is then mixed with water and ground finer in rotating mills until it's as fine as powder. The iron-bearing mineral called magnetite is separated from the non-magnetic, non-iron-bearing waste rock using magnetism. The remaining rock is waste material called tailings and is stockpiled in large basins. The magnetite-bearing material has now been upgraded to higher iron content, now the size of fine sand, and is called concentrate. Some mines use a process called flotation to further separate the iron from unwanted materials such as silica by placing the concentrate in the slurry in large vats that froth or foam. The higher concentrate iron slurry is then separated by large vacuums which draw off the water, resulting in a drier cake-like substance with more iron and less water. The concentrate is rolled with clay inside large rotating cylinders. The cylinders cause the powder to form marble-sized balls. This is like rolling wet, sticky snow into balls to make a snowman. The balls are then heated until they're red hot. The balls become hardened and eventually cool. The finished product is an iron ore pellet containing 65% iron and designed to melt efficiently in a blast furnace. The iron pellets are transported by rail, most often to ore docks, where they're loaded into lakers along the shore of Lake Superior. These ore boats sail on the Great Lakes to Gary, Indiana, Cleveland, Ohio, or other steel-making towns in the Great Lakes region of the United States, where the steel mills melt down the pellets in blast furnaces to make the steel used to make the products that we use every single day.